Alright, so in this problem we want to solve this quadratic equation by showing and explaining the decision-making process to find a solution. So first we have to check if it's a perfect square and solve if possible. So it's not a perfect square since it has 18D. Alright, so we've got that. If it's not a perfect square, explain why. So we did that. Then it says, can you solve by the zero product property? Okay, so the zero product property okay, so to do that I have to check to see if I can factor it. So I have d squared. Oh, I need to add 7 to both sides. So actually let me do this. I want to add 7 to both sides first. So then I get d squared plus 18d plus 50 equals 0. Then I want to try and factor it. Alright, so when I go to factor it, d squared plus 50, and so my factors of 50d squared I want to add up to be 18d. So I look at the factors, whoopsie, 1 times 50, 2 times 25, and 5 times 10. So I want combinations of my factors that are going to give me 18. Well, this is 51, this is 27, and this is 15. So clearly we can't factor. So the zero product property will not work since it is not factorable. Alright, so now the only other method we have is to solve using completing the square. So to complete the square, I'm going to so I'm just gonna do this work. So we're trying to complete the square on this. So I've got d squared, and then I want this to be 9d and this to be 9d. So then I have d plus 9 and d plus 9. And so this here has to be 81 to complete the square. So if that's the case, if I have d squared plus 18d plus 50, and I need to complete the square, then I need to add 31 on this side, and I need to add 31 on the other side. And so I get d squared plus 18d plus 81 equals 31. So this is a perfect square, and that will factor to be d plus 9 squared equals 31. And then to solve this, I'm going to take the square root of both sides. So I get the absolute value of d plus 9 equals root 31. And so then this ends up being d equals minus 9 plus or minus root 31. And that is my solution. So the zero, completing the square works. And then for 4, I did not need the quadratic formula. So the idea here is if completing the square wouldn't work, then we would have gone to the quadratic formula, but we didn't need it because completing the square worked out just fine.